All right, folks, it's back in action here. In this video, we're going to cover our basic trigonometry. You will need a scientific calculator for this video, and you're going to need your scientific calculator set to degree mode. Okay, so make sure that you've got a scientific calculator handy and it's set to degree mode. I'm going to go through a lot in this video. You might need to pause it to keep up because it's going to go fairly quickly. First thing that you might want to write at the top of your paper is the good old SOHCATOA, okay? Our sine is going to be our opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent, okay? Now, the most basic version of this problem, we're going to start with finding sides, would be you have a nice right triangle. SOHCATOA is only going to work in a right triangle. Remember, we only have a hypotenuse in a right triangle. So you're going to have a right triangle. You need to know a side and one of the angle measures. So we can start by trying to, let's say, find the remaining leg. We could have found the hypotenuse. I chose the remaining leg first. So I'm going to call that remaining leg, I'm going to call it X. Whatever angle you are given, you're going to use that as your point of perspective for the problem. So from that angle that you're given, we're going to recognize that this 10 on this triangle is the adjacent leg, and the X that we're trying to find is the opposite leg, okay? So that means that we have the adjacent and we want the opposite, and when we look up here, that's going to be tangent. So when we set this problem up, it's going to be tangent of 19. That's going to be a number in your calculator, is going to equal the opposite, in this case X, over the adjacent, in this case 10. Since tangent 19 is a number in our calculator, we can visualize that as over 1 and we can cross multiply. So that's going to give us a nice X equals 10 times the tangent of 19. Now, trigonometry is not going to give us this basic SOHCATOA trig, is not going to give us an exact answer like we've been doing. So when we type this in our calculator, we're going to get an approximate answer. The problems will typically tell you how to round it. On our example today, I'm going to round to tenths. So if you type this in your calculator, you should get 3.4 units. If you're not getting 3.4, it means your calculator is probably not in degree mode, or possibly you're using your parentheses wrong, in which case I would suggest just showing me your calculator and I can help get that fixed for you. Now, to find the other side, to find that hypotenuse, we do not want to use the Pythagorean theorem. Remember, Pythagorean theorem is going to square our sides, which means it's going to square this approximated answer. So we're going to do trigonometry again. That means that my perspective is still going to be 19. I'm still going to know that the adjacent leg is 10, but now I want this side right here. I'm going to call it Y, and I'm going to recognize that it is the hypotenuse of the triangle. So now I have the adjacent, I want the hypotenuse. That means I'm going to work with cosine this time. So this time I'm going to say cosine of 19, adjacent is 10, hypotenuse is I don't know, I'm going to call it Y. I'm going to visualize that cosine 19 over 1 because it's a number, and I'm going to cross multiply. Now this one is set up a little differently, so when I cross multiply, now I'm going to have Y times the cosine of 19 equals 10, which means Y equals 10 divided by the cosine of 19. You've got to be careful that you're doing that algebra in the correct direction. We'll type that into our calculator. Again, in that degree mode, it's going to give us an approximated answer, and we're going to round again to tenths, and we'll call it 10.6. You could do a quick check with your Pythagorean theorem, and you should get really, really close using that converse Pythagorean theorem, and it should be really, really close. Now we're going to look at two word problems. On this word problem, I've already kind of set the picture up a little bit, but I haven't labeled it. It says that a plane is going to take off, which means shoop, it's going to take off. So the plane's going to take off and it's going to use this language, angle of elevation. An angle of elevation with the ground is 18 degrees. Angles of elevation are going to start at a horizontal and open up. So the 18 degrees is going to go right here. When it reaches an altitude, that means how high off the ground is it, of 3,000 feet. So the 3,000 goes right here because that's how high is the plane off the ground. And then it wants to know how far is the point that's directly below the plane, that's this point, from where the plane took off, that was right here. So this is the x that we're trying to find. So the angle that you're given will always be your point of perspective. X in this case is going to be our adjacent leg. The 3,000 is going to be the opposite leg. So again, I've got an O and an A. That's going to be my tangent. So to solve for this problem, we're going to say the tangent of 18, opposite 3,000 over the adjacent of the x. I can visualize this as over 1. When I cross multiply again, I can see that I'm going to end up with this division. So when I type this in my calculator, it's going to be x equals 3,000 divided by the tangent of 18. Well, to get our approximated answer, we'll round this to the whole number. In this case, again, the problems will usually tell you this would be 9,233 feet. Now that's a kind of an odd kind of an answer, although the problem started off as in feet, but it might ask you to convert this to miles, 5,280 feet in a mile. So we could work that out and we would actually, if it asked for it in miles, we'd get about 1.75. But we'll leave it in feet. Our next one is going to be our person on top of a lighthouse. Okay, so I've got some person that's up here and they see this boat down here in the water. Now this problem says that we have an angle of depression. Angles of depression are often challenging for students, okay? So the person is up here and they look down. An angle of depression has to be formed from a horizontal line, okay? So when my person looks down to the boat, the angle of depression actually goes right here of 25 degrees. Now, if you think back to the geometry, this horizontal line is parallel to the water, so we have some nice alternate interior angles. So you could take that 25, this is what I like to do, and I like to fill it in down below. My lighthouse is going to be perpendicular, so I can put in that right angle. It tells me that the boat is 22 meters from shore. So this is going to be a nice 22 here. And it wants to know how far is the person, that was the person that was up here, from the boat. So I'm going to put my X right there. So now, my 22 from my point of perspective is the adjacent. My X is the hypotenuse. So I can see that once again, I'm going to use cosine on this problem. So I'm going to set this up as the cosine of 22, or cosine of 25, I meant to say there, sorry. Cosine of my 25 is going to equal my adjacent of 22 over my hypotenuse of x. Again, I could put that over 1 if you've caught on to the pattern. When we type this in our calculator now, it's going to be 22 divided by the cosine of 25. So my approximate answer is going to be 24.3. We'll label this. Our problem is in meters, so that would be that problem. Now, I'm going to go ahead and I'm going to move on to finding the angles. Okay, whenever we want to find angles, we're going to need to remember to use our second or our shift button on our calculator. Okay, that's going to have our calculator go backwards. So if I want to, let's say, find the measure of angle U, From angle U, I can see the two sides I've been given. 9 is an opposite. 17 is a hypotenuse. So I can see that this problem would be set up as the sine of angle U is 9 over 17. To type this in our calculator and get the angle U, this would become inverse sine, telling it to go backwards, is 9 over 17. When we type that in, we'll get an approximate angle and we'll round it to the whole number of 32 degrees. Again, the problems will always tell you how to round. If you wanted to find angle D, you could do trigonometry again, but we could also just recognize that these two angles should be complementary. So the measure of angle D is just going to be 90 minus our 32, or 58 degrees. To find our UG, notice it's a right triangle and we know two sides. We can do just a quick Pythagorean theorem on this. We don't need trigonometry. 17 squared, 9 squared, plus x squared. It's going to give us a square root of 208. Since we have a way to do it exactly, we would want to use this exact strategy. This would simplify to 4 square root of 13. All right, let's look at two quick little word problems. On a particular day, we have a tourist. You'll notice I've kind of again set this up. They are standing 94 feet from the bottom of Willis Tower. That's the Sears Tower in Chicago. So we've got 94 here because our person's way out here. And he remembers that the tower is 1,450 feet tall. Okay, he's like, oh, I think it's around 1,450 feet. So we want to know what is the tourist's angle of elevation looking up to the top of the building. Remember, it starts as a horizontal and opens up. So this is going to be an X. So now, the height of the building is going to be the opposite. The 94 is going to be the adjacent. So now we can set this up and find the angle by saying the tangent of angle X is our 1,450 over our 94. So when we type it in our calculator, we will say inverse tangent of 1,450 over 94. Now, if you're struggling to type this in your calculator, again, just bring your calculator in and I will show you. So his angle is about 86 degrees. And if you've ever been in Chicago and looked to the top of the Sears Tower, you know that, yeah, you're looking probably pretty much straight up, so that 86 degrees makes sense. Last one we're going to look at is going to be a zip line, okay? So we've got a zip line. The length of the zip line is 36.5 feet. Remember, the zip line is the physical line right here. So this is going to be 36.5. The bottom of the zip line is 24 feet from the base. So from here, so this is going to be our 24. I want to know the angle of depression from my person standing up here. But remember, angle of depression would be this angle, but it's going to be congruent to that one down there. So I'm just looking for, this is an X. So I've got an adjacent, I have a hypotenuse, so I've got a cosine. So cosine of X is adjacent over the hypotenuse. To type it on our calculator, we're going to say inverse cosine of 24 over 36.5, and we'll get approximately 49 degrees. All right, so that's a quick review of basic trigonometry, and we've got some practice problems, of course, for you to do.